Good evening, everyone. How is everybody today? Um, so yeah, I'm going to be hosting this evening. Kira's asked me to host this evening. Kira does such an amazing job of these presentations. I don't know why she's asked me. Yeah, I'm really glad all you guys can kind of join, and we're going to go through kind of the next chapters of books. Probably just hang on, maybe just for a minute, just see if there's any other late joiners, and then I'll kind of like crack on. So feel free to talk amongst yourselves. If you got any messages in the chat, Kira will prompt me with those, no doubt. So feel free to write in the chat or speak out. So if you want to open up your mic and talk, that's also cool as well. So if you got any questions or anything during the presentation, then I'll pause and ask for questions if there is any. But if you got any burning things straight away, you can ask them. You don't need to worry about being polite. Cool. All right then. I will start this book club session then. So yeah, welcome to the Rust and Cpp book club in Cardiff. I should probably add. We are. Yeah, so we got our handles for social media, which you probably know already. We're trying to get a bit more traction on Discord. So if you're not part of Discord, come on and ask your questions or share and help others. It's very much a two-way conversation that we kind of try to create. So more of like an environment and a culture rather than just kind of like a one-way conversation. So yeah, feel free to kind of get involved with Discord or message up on Twitter. So the objectives then for the Rust and C++ group in Cardiff is, to learn and share the languages of both Rust and C++, introduce new people. We want to kind of challenge ourselves, from technically and also from like presentations as well. So if there's other people, if you're interested in giving a presentation, then let us know and we can do one next time. We always try to kind of keep it within real world solutions. So I know sometimes it gets a little bit abstract, a bit too high concept, but we try to bring it back to real world so it can be practical. And yeah, just get better at these both highly performant languages that we have a lot of passion and love for. We are sponsored by Esri. So Kira and myself both work for Esri. So that should just be known before going forwards. We have a conduct. Our code of conduct is based on the Rust code of conduct, which is, just be wonderful to each other, really. Just be nice. And we've got this idea of a Pac-Man rule, which has more, accuracy in the real world when we used to do real world meetups, but it kind of works virtually as well. It basically is like if you have a conversation with somebody in the group, make sure that you always kind of allow other people to get in or leave a space for people to get involved in that conversation as well. Cool. All right. Well, welcome to the Cardiff Book Club, Rust and C++ Cardiff Book Club. And we're going to be going through chapters 7 and 8, I think. I hope so. Right. So recap on last week, we did some structs, enums, and pattern matching. And in week 1, we did, these are what we've done for the last couple of weeks. So we've installed the tool chain, basic programming concepts, structs, enums we did last week. And this week we are doing chapter 7, which is managing growing projects with packages, crates, and modules, and chapter 8 on common collections. Before we kind of move on, Kira, is there any polls or anything that you want to give or offer before we get?
Yes, just similar to what we've done before, just to see where everyone's at with going through the books. Obviously, we're all kind of working through it independently and then just having these sessions to touch base. So I've just launched the poll to see how far along people have managed to get. I know some people come along to these later and haven't necessarily been to the previous ones. It's just good to get an idea.
I think you might be, oh, that's me not scrolling properly. Just ignore me.
Yeah, we've got at least one first timer. Welcome.
Hello.
Hiya. Oh, I just realized there's a mistake in the last question where it says Rust dev setup, but you know, you get the idea. Okay, great. I will wrap up the poll there. It seems like most people have gotten through at least the first few chapters. Everybody's passed chapter 4, which is one of the most important ones, and lots of people have had a chance to get through chapter 7 and 8 already, which is great. Some people have gone beyond. Yeah, and most people have been to meetups before, which is awesome. I will let you carry on. Sorry, I just realized I didn't share the results. There you go, everyone.
Great, thanks, Kira. Yeah, for those of you who have passed chapters 7 and 8, feel free to kind of chip in with some of your insights that you might have as well. We always kind of value that kind of conversation, so feel free to do so. Cool. All right. So, okay, chapter 7 from the Rust book, managing growing projects with packages, crates, and modules. So this chapter is kind of broken down into 5 sections: packages and crates, defining modules to control scope and privacy, paths for referring to an item in the module tree, bringing paths into scope with the use keyword, and separating modules into different files. I would argue that, you know, this is probably what defines Rust. So it is quite an important chapter. So thank you for Kira to entrusting me with this one. So let's define a couple of things. So a crate can be a binary or a library, and its root is a source file of the Rust compiler. So when you build it for the first time, it's going to be looking for that main.rs or lib.rs. And a package is kind of like a collection of these kind of crates into one. And then that package contains a cargo.toml, which is the definition of how to build those crates. So here is a hastily drawn diagram of it kind of like put together. So with the example of like an awesome game engine, in this case, my awesome game engine is a package, and it wraps up these 3 crates, which is part of my game engine, which is the graphics, the maths, and the logic. So that's just a kind of example of kind of how these packages and relationship with crates. I hope that's clear enough. If it's not clear, let me know and I'll talk about it in more detail. Right, okay, well, as I said before, there are 2 different types of crate. There's a binary crate and a library crate, and we're going to be looking over those right now. So when you build a new project with cargo new and the name of your project, what you're doing is you're using the default setup for a binary crate. It's exactly the same as if you called cargo new --bin. That's a more explicit way to do it. And what it'll do is it'll create your source main.rs with your main function in there and your hello world template all ready to go. And the other one is if you use the --lib in the command in the command line argument for cargo new, it's going to create your library crate. And the difference is there is that it's going to contain a lib.rs, not your main.rs. So then they'll compile it as a library rather than an executable. So you can use that library in other projects. So a package can only contain 1 library crate. Okay, I didn't write this slide. This is, but it can have multiple library crates for placing additional files in the source bin directory. Each file will be separate binary crate. Okay, Kira, do you want to elaborate on this one quickly?
Yeah, so this is slightly different to what you might see in some of the more complex projects where you have a concept of a workspace, which would be a package within a package. Because we're talking specifically about packages and crates, your package would just be one library crate, which is the one that would have all of that shared functionality, but you might have some additional binary crates, like for example, a command line interface or a graphical interface, which might be different executables that you want to be delivered with your library crate, but aren't necessarily, they're not ones that you're sharing out. They're kind of more self-contained, if that makes sense. Whereas if you wanted to have multiple crates, which were libs in their own right, then for that you would use a workspace, which would then bring together your multiple packages, which I think comes on in, I think it's in chapter 14. But for the difference between packages and crates, this is the kind of the crucial bit is, yeah, there's just one library crate in a package, which is something that I didn't have the terminology nailed down before I was going through this chapter in a bit close detail. I think it's kind of a nice one to get clear in your head, because otherwise you end up trying to do things that aren't possible.
Right. Yeah. So just kind of thinking about I think there's a Vulkan crate that has multiple bin projects in it, and you have to call those bin projects for examples. There's one for examples and there's one for another one, and you have to call them separately, and that is part of the same crate. Okay, thank you.
Part of the same package.
Yes, sorry, that's what I meant. Sorry.
The two words get used interchangeably because most packages people think of as just containing one crate, which is why people use crate to mean package, which is why all the terminology gets a bit muddled, but trying to stick with their official line, even if that's not how they use it in all their documentation.
So yeah, we're going to be moving on to modules now, and scope. So if there's any questions about those, about the differences between packages and crates, I'm pretty sure we had it all worked out, and then I think evidently just then we got confused again. So if you got any insights or if you've got any more questions, let us know and we'll kind of talk about it a bit further. But you can use modules in your code to kind of break your code into manageable files, which we'll see later, or scope, which becomes a lot easier if you're familiar with programming. If you have unmanageable code in one file, then it can be quite difficult to work with it. So it's going to be, incidentally, the new C++ module language feature that kind of bringing in is going to be very similarly based on the Rust modules as well. So what is a module and how can we use it? So a module here is defined with the mod keyword, and in this example from the book, we've got a front of house and we've got a hosting module in here. So we've got a nested module. We've got a serving module, which is nested in as well. And then we've got these functions in these modules. And these functions within these modules don't know about each other because they're in the scope of this module or of their modules. So if you kind of think about it as kind of like a directory tree, these functions here, they are siblings and they can kind of see each other. But parents, if there's one that exists in a parent, then they can't see it. It's the same as kind of like a directory tree. So to kind of use these within your code, you can use like absolute paths or relative paths. So an absolute path is using the crate keyword, and then you can get its like namespace from there, which is colon, and you kind of get it from there. Relative path is if we think about the file structure again, then the front of house is its sibling, so we can just get to the front of house and then we can get to the function as well, which is more interesting when it's on the next slide. So yeah, this slide is just basically reiterating what I just said. So yeah, using super is interesting because super allows you to go up one on that kind of directory path. Do we not have a slide for that? Okay, I thought we did, but we might get onto that in a minute. So within regards to kind of public and private, so as you may or may not be aware, if something is public, then it can be accessed from across the scope of the project, whereas if it's private, it can't be. It's kind of hidden away within its scope. So by default, in Rust, functions and methods and structs and enums, everything is kind of like defaulted as private. So in that case, you know, a parent module can't use the private items inside the child model modules, and we can see that in a minute. So in order to get around this, we can use the pub keyword, which is short for public, and then it exposes that function or struct or enum within inside that module. So in this case here, what we've done is we've exposed the module hosting. This is in the example. The examples have exposed the module hosting. But what's interesting is that add to waitlist has not been exposed because it is lacking the pub keyword here, so it's not public. But hosting is, so we can get a hold of hosting here, but we can't access that function because it's hidden away. Now, to get around that, what we can do is we can just add the pub keyword to the add waitlist, so we can actually access it now. Or if we wanted to, because front of house is not public, what we could do is we could put the pub on here, and then everything underneath it will be accessed as well. I think maybe this still needs to be pubbed as well. I'm not sure about that actually, but it's one for chat. Okay. Oh yeah, so we do have one for super. So yeah, without the pub keyword, only siblings and ancestors are accessible. So we can use the super keyword, which I said earlier, which is similar to kind of like the ellipses to go up one in that kind of file hierarchy for modules. So here in serve order, which is up one outside of this module in this ancestor, we just use super and serve order, and we can get up to there. Yeah, so yeah, some important things here. Yeah, marking a struct as public does not make its fields public. You have to do them individually, and marking enum public does expose all of its variants. So just a little bit of implementation detail there to be aware of. So we can see that here. So we've got an implementation here of breakfast of the struct breakfast, and it's just an implementation of it. Okay, yeah. So this is just breakfast with its struct. We've publicly exposed toast with a string, but seasonal fruit is private. So, oh right, yes. So we can call the public functions set in private fields, which set private fields, but we can't access the private fields directly within inside structs. So, maybe on the next page here. So in this case here, let's just go back one. We will not be able to get access of seasonal fruit in that case. We will need to get that public function, which is set private fields, but can't access private fields directly. Yeah, okay, all right, so it's about nesting, obviously.
So here, orders setting the seasonal fruit as peaches, because that's a public function. So that's setting the seasonal fruit, but you can't modify it after the fact by doing meal.seasonal fruit. And I think that's just what this is showing.
Yeah. Cool. All right. So we got enums. So enums are public. So sorry. When you make an enum public, then all the definitions for it is kind of set underneath. So here, well, to get it to it quite easily, you know, you just go through the module path, as it were, to get hold of what type of enum value you want. Right. Okay. So another way to kind of bring paths into scope is to kind of use keyword. So I think you'll see this quite often, and the Rust analyzer does a good job of kind of automating this process for you. So when you kind of add kind of like a function from a different module, what you can do is you can just use the use up here, which just kind of like for declares, or it just kind of defines that you kind of want to use this within this scope. You want to use this path as in the scope. So you can just use hosting : get add waitlist. It just kind of shortens, it makes your code a little bit easier to read. Yeah, similar to creating a symbolic link in the file system. Right, so bringing a parent. Am I still live? What's going on here?
Yep.
Okay, so bringing a parent path into scope rather than function directly makes it clear the item is not defined locally. So yeah, so these are just ideas that you can use. Now, I'm not going to tell you how to write your code, but it's preferred to have at least the last part of that namespace for that function call, which is outside of that module, rather than add to waitlist, because it could be a little bit harder to read. But that's your decision to make. Right, so for struct and enums, it's conventional to use the full path. So in that way, you don't have to have that little bit on the front of that path. You can just have that function, that struct or that enum name directly. But that's your decision to make. You might argue that it might be easier to read like this or not. So that's kind of your decision to make. Okay, so this is interesting. You can also use like a alias path as well. So in this case, what we're doing is we're returning an IO result, and we're using IO result as a standard IO result here. Now, I personally, I don't like to do that, but you might find reasons to do it, and it's your code, and I'm not going to tell you how to do it. But it's quite similar to Python, so yeah, it's got that as well. Right. This is really interesting as well. I haven't really used this much, but this is quite good for library writers. Is to re-exporting the path with the pub keyword. So, for example, in here that they've offered is back of house, and they've publicly exposed the use for the front of house, the enum course. So what's quite interesting here is that if you've got like a library that's doing lots of different things, then you can kind of hide away some of that kind of implementation detail, or some of those requirements for different modules that you need. So that's pretty good. You just excuse me one moment, I'll be right back.
Yeah, I quite liked the that kind of exporting, but I've not. It was a bit interesting because obviously it makes it look like something's in one place when it's somewhere else. But I hadn't. Last time I've been through these chapters, I hadn't kind of noticed that, and then seeing it this time, it was quite a nice little trick to have. Yeah, definitely. So so I made the point it's good to be aware of when you're reading other people's code, because things might not be in the file you expect, and that's definitely true. It's like it's fine when you're only on the outside and it's just, but then if you try and go any deeper and dig into someone else's code, you'll be like, where on earth is this thing that I just have been calling for ages, but now I can't seem to find.
Right, yeah, sorry about that. Okay, so this is really important, and in the book it kind of only touches on very, very briefly in this chapter, and it is one of the most, it's one of the best strengths of Cargo and Rust, and that is including other external packages that other people have written in your Cargo TOML. So in this case, in our Cargo TOML, there's a dependency header, or I'm not totally sure what this is in TOML, but I think it's like a header, and then you can define what crate you want, or package that you want to get Cargo to go away, find, download, and add it to your project. And crates.io is kind of where all of that kind of lives. So let me, so here it is here, this is crates.io, and you can publish your own crates quite easily. It's very easy to do. And here we just got a list of everything. So for example, you know, if you wanted to get some sort of graphics engine, so I know for a fact that Ash is a Vulkan binding for Rust. We just come into Ash and already it's got some examples on how to use it. And then you just add this line here, which has already got a copy button. You add that to your dependency in your Cargo TOML, and it'll download and you're kind of ready to use it. And then you can just, you know, use all the things that we just learned for using and modules and kind of what we just went over, and you can use that library directly within your project. It's really quite powerful, and I'm surprised that it's only got a very light mention here. Maybe further in the book, Kira, maybe there's more about.
Yep.
Yeah, there is. Okay, cool.
Yeah.
That
Don't
makes
you
sense.
worry. Chapter 14. It's all there.
Great. So the standard library in Rust is a crate, but it comes with the Rust compiler, so you don't need to add it to your Cargo TOML, and the standard library is pretty powerful. So another thing about multiple items for your crate or module, you can use nested use statements, and the Rust analyzer in Visual Studio, which is a Visual Studio extension, I think Cargo Format does it as well, which is a tool for the Cargo toolchain, will automatically kind of bunch similar or common paths for your modules in this way. So yeah, there's just some more examples that the book kind of give. You know, if you wanted to use standard IO and also the right enum or function struct from IO, then you can just use self, which kind of references the one up to include IO as well as the right enum or struct. I'm not entirely sure what this one is. You can also use a wildcard or a glob to pull everything in within that that path. I personally don't like publishing with that, but that's your decision to make. Okay, so yeah, now we're going to be talking about how to use kind of modules to separate into different files. And this is something when I started using Rust, I kind of struggled with initially. So we're going to go over in a bit of detail here. Well, I hope detail, just to make it a little bit easier to understand. So the reason why I had quite a few problems with this is that there's quite a lot of rules, and Rust is very pedantic about how modules and files and the file structure, the actual file structure on your disk is arranged. So in this case, we've got two files. We've got lib.rs, and we also have front of house.rs. So we've got two different code files. And to use front of house.rs, we want to define the module that we want to use, which is front of house, and it will go away and it will find front of house.rs. Okay, so you're not including any actual files like in C++, you're not using a hash include, but what it's looking for is a file with this name, and then it'll add rs on the end of it. So it will warn you if it can't find things, and it will try to suggest the naming conventions that you should be using on your disk, but just be aware of that. And then we can just kind of bring it in as usual with our use, and then boom, we've got a hosting.add to waitlist. What's important here is that because it is in a separate file, we need to make sure that it's pub hosting so we can get a hold of it, and it kind of publishes it out so we can get front of house. So to go into that in a bit more detail, Okay, so I'm going to probably skip over this one here. I'm just going to go straight into this one, and I'll talk about it a bit more detail here. So here we've got a file structure of a project, or a slice of a project that I've been working on. And here we got our lib.rs, which kind of defines and uses some of these data. We'll look at the code in a minute for it. And we've got a voxel data.rs, which is separated out of voxel model.rs. And then we've got a folder called Asset Baker, and in there we've got our mod.rs and voxels.rs. So what will happen here, I think the code kind of goes through it maybe. So in our lib.rs, what we're trying to do is we're trying to get into and use our voxels within our Asset Baker. And what we need to do is have a mod.rs, and the mod.rs is like an entry point. So what you could do is you could have an asset baker.rs, okay, but I wanted to split out the voxels part of that asset baker into a separate file because it was getting quite large. So in order to do that, you need to kind of like a definition of the module asset baker. And in mod.rs, you kind of define another module for what you want. So in this example, I'm using voxels. And then it's when you're in your lib.rs, which is the top part, I can just do asset baker. I just assign or declare the module asset baker. And then that will kind of bring in that mod.rs. Oh, I think that's supposed to say mod.rs, not voxels.rs. I apologize for that. And then it can bring in the voxels. Is that clear as mud? Is that any questions about that? I appreciate you. Yeah,
Got a
I
question.
appreciate the feedback. Yeah, is there still a source somewhere? Yeah, so yeah, up here there would be a forward slash or source. This would be source up here. So maybe I could have made that a bit clearer. I apologize for that. But yes, this is your forward slash or source forward slash file folder in here. Cool. All right. Well,
just wanted to add, like, I think one thing I found really useful with this section is going through some of the crates on crates.io, and they all have public GitHub links. So then you can go through and see how some of the projects that have been published, especially the more popular ones, see how they've actually arranged it. Because I found it a bit strange initially trying to match up, like, you've got the pub keyword, you've got the mod keyword, what needs to be public, what doesn't need to be public. But when you go through some examples, it can sometimes make it a bit clearer.
Do you have any recommended crates for that?
I know it's not a small one, but I found the Rand one helpful because it's got a package within a package, which it does touch on later. We haven't, in fairness, gotten to it yet, but the idea of having a workspace which would then combine multiple packages. So on crates.io, there's Rand core as a package, but you never really use that directly. It's just used in the context of Rand. But Rand core is its own package within another package, which is slightly different to what's covered in this chapter. But then within one of those packages, there's lots of stuff, kind of lots of things are pub, lots are not pub, and you can see which ones are exposed and how they're used in the examples and stuff, which I found quite nice.
Great, thanks, Kira. Maybe we'll explore that later. Right, okay, well, that is the end of chapter 7. I hope that made some sense. But in summary, so you can split a package up into multiple crates, and then a crate you can split up into modules to make your code a little bit more easier. You can refer to items in a module using absolute relative paths. You can use the use keyword to bring path into scope. And then module code is private by default, so you need to make things public. But the Rust compiler will definitely tell you and suggest that you should be making things public. So you're it's kind of holding your hand there. Do you have any questions about chapter 7 before we kind of move on to chapter 8?
Maybe I would have one quick question, and hopefully that's not bothering anyone. The difference between the library and the binary flag that you can set, besides the fact that it's creating like the main.rs and what was the other one, lib.rs, like Is they're still just source code files, or what's the I'm not sure. I'm coming from maybe as a quick introduction from Python, so I'm not really used to that kind of concept here and the split there, because everything is kind of a source file or a module in a way. Sorry that we have to go all the way back.
No.
Earlier, but yeah.
No. Do you want to explain this, Kira, or do you want me to bumble around and try to explain it?
So the way I think about it, I'm by no means like an expert, is a binary is an actual executable. So that's the kind of the main difference. And normally when you're talking about a package, in the majority of cases, it will probably only have maybe one executable, but you might have one with multiple ones. And that's where you bring in multiple binaries in the same package. And then a library, well, the nice thing about a library is that you can actually access it from other stuff. So if you created a binary crate, it's not going to be accessible from any of the other crates that you might have created, whereas your library crate, that's where you put the shared code. So in an ideal world, you'll put pretty much all of your code will be in libraries if you want to share it, and then the binary executable will just be very small self-contained thing, because you can't test the main function, and because you can't test main.
So the library would the library code that you end up importing from somebody else and using, that would compile when you with your stuff when you do it, and then in the binary format, it's as you mentioned, just an executable from the start.
Exactly. When you run it, you're just running their executable if you pull down someone else's binary. But for a library, you can actually use their code, which is
the functions and modules don't ever. That clarified it. Thank you.
What's also handy about that is that you can have multiple binaries doing different things. So, for example, if you want one for a different platform, then you can have different binary projects.
Yeah, I think somebody just said in the chat, it's the difference comes up in Python sometimes with the if equals main trick, and where if the top level file that's being executed is like the main function. Thank you.
No, thank you for your question. I'm glad we could clarify that. So just a side note, okay, that publishing crates or packages to crates.io is extremely easy. There's the cargo toolchain kind of allows you to do it. I think it's just like cargo publish, and then it kind of publishes up your project. It does compile your source code that you have in your documentation to make sure that all kind of works. And you also need a public Git repo as well, if I recall, that it kind of needs to hook onto, and then it'll automatically generate your documentation and things from that, and then it'll publish onto crates.io. I think there's maybe an additional button that you need to press to do it, but it's very easy. So, and a lot of people are sharing stuff. So if you just got like a small little library that you think is kind of useful, maybe you're doing some sort of like, I don't know, some sort of color palette switching or something like that. If it's just a small part, you can just publish it up, and people are going to use it. So I've published a couple of things to do with manipulating music and music time. So there's quite a lot of like music maths in that, I suppose. And Alex, who is another host in our group, he uploaded. He's done quite a few talks, and he's doing another talk about it somewhere else tonight about uploading a couple of packages for face tracking movement and using the GameCube bongos at the same time. So he's got a whole library up there for. I don't know why anybody want to use that, but that's him. Cool. All right. So chapter 8, common collections. So there are 3 sections in this book: storing lists of values for vectors, storing UTF-8 and encoded text with strings, and storing keys with associated values and hash maps. These titles I find in the book to be a bit scary. Literally all it's about is, hey, vectors, 2 strings, 3 hash maps. So there we go. So let's look at vectors first. Well, a vector in Rust is of a vect t. So any type can be held within a vector, but it has to be of the same type, and then is laid out in contiguous memory. So it's kind of laid out after each other, which is different from Java, if I recall correctly. But I'm not going to get into that right now. So, okay, so how can we, well, create a vector? Well, it's quite easy. All you do is just, we have a vector new, and we just create a new vector. In this case, though, we have to have an annotation because it, Rust can't derive the type that we're kind of putting into it, and we'll kind of see that now and in a minute. So we can also use the vec macro. So quite easily, we just put in our values in here, and it will infer the type that you want, and it will create us a new vector, which is pretty easy. So in this case, I'll probably create int32s. We can also use push to add more elements into a vector. So we've kind of created our vector here, new again. It's mutated or mutable, so we can now push our values into it. And as you can see, there's no annotation here, no type annotation here, because it's looking ahead and it's deriving the type from the values that we're kind of pushing in later on, which is pretty cool actually. Oh yeah, and even though in the book it doesn't talk about removing elements, I just thought it'd be just handy to talk about pop, which removes an element. Very similar to collections, interface to collections in other languages and libraries. Another important thing here is that, you know, a vector is freed when it goes out of scope. So it's not like C++ when you're trying to create a new vector or a unique, so yeah, just be aware of that. Okay, so this is quite powerful with vectors. You can use square brackets and the index to get at the index of your collection, which can be quite dangerous because if it's out of scope, well, not out of scope, what's the word? Out of, what's it called when it's out of
out of
range? It is out of range, yeah, sorry. If it's out of range, then it's going to panic. So a safer way to do it is to use get, and get will return an optional, and in this case, that optional is being used in a match. It's a lot safer, but that's up to you. So yeah. The other thing is about vectors is that they enforce ownership. So in this example here, we are taking the first element in the vector and we're kind of borrowing it as first. We're then trying to push a new element onto the vector, and at this point, the compiler will be like, hey, you can't do this because you're also borrowing it elsewhere. So you just be careful of that, and it can be quite difficult to work with. But to resolve this issue, I'm pretty sure you can just switch these lines around, or you can put them into scopes, and it'll kind of fix this.
It's worth mentioning, if you weren't using first on the last line, it would be fine, because it would drop it would say that first is out of scope, because the scope's determined by the last time it's used rather than by any curly brackets or anything, which is quite nice in Rust.
Thank you, Kurt. Okay, so you can use iteration to access all your elements. So you got a for I in V. So for each element in the vector, I think in the book they could have used a better naming convention, make that a bit easier to read, for me anyway. So just like most other languages. And then if you want to mutate those values, then you need to add the mute keywords to that as well. The reason why we're doing these by reference, because if you don't do it by reference, what it will do is it will take the first element and move it, and then when it gets to the second element, it'll be like, hey, you've already moved something from here and we can't get it, and the compiler will complain about this, and it will suggest what you should do. So when you're working with iterations and vectors, you've got to do it by reference. So if you do want to store different types in your vector, you can use an enum, and in that way you can store different types, and then you can kind of go through the iteration and have a match, and then you can pull out stuff from it that way. Okay, so that is vectors. Is there any questions about vectors before we move on to strings?
I had one thing that I thought was kind of important to note, which is that if you are removing items for your vector, it's just important to be aware that your vector is never going to resize to get smaller. So you're still going to be using that memory unless you call shrink to fit. I think it's similar in other languages, but it's always nice to know what that method is. So if you've made your vector and filled it with 1 million elements, even if you get rid of them all, until your vector drops out of scope, that memory is still going to be allocated unless you do shrink to fit.
Yeah, with that, I also kind of argue as well that if you're creating a new vector and you know the size of it, I would recommend you do create with capacity or create with size. I can't remember what the function name is, but what you'll do is you kind of limit the size of the vector. It'd be a bit easier to optimize for your compiler. So yeah, good point there, Kira. Yeah, vectors are all heap allocated. That's correct, Philip. Right. Okay. So strings. Okay. Now this is probably the biggest challenge that I had with Rust is working with strings. I've come from like a C++ kind of background, where I can just kind of do whatever I want with them, and kind of it was quite difficult at first, but now I'm really kind of grateful for the strings in Rust. So, unlike most languages that I know of, all encoding of characters is in UTF-8, which is, I think, modern and easy. And I think it's, you look at how C++ handles, UTF-8, and it's quite difficult to work with. So in hindsight, I think Rust have done a great job here. So anyway, string is kind of part of the standard library. It's kind of growable, mutable, and it's owned. And a reference string or an at string is a slice of a string, and that was kind of covered in chapter 4. So if you forget, or if you want a refresher, I suggest you go back to chapter 4 to learn about slices from strings. There are other string types as well. We've got OS strings, which are, I believe, are operating system specific strings, and you've got C strings, which are your classic C string. So that's kind of used for creating, your ABI, your cross library binaries, so work with C. But if I don't really know much about these, but if anybody has, that'd be great. But yeah, no, I totally agree with you. I think Rust strings are fantastic. Yeah, strings are complicated everywhere. Yeah, you're right. No, I agree. I think the general consensus is that Rust strings are difficult to work with initially, but they are pretty good. So how can we create a string? Okay, well, it's very similar to a vector because a string is just a collection of characters. So we can just do new, or we can take a string literal, which I believe is an at string slice, and then you can just convert that to a string. So it gives ownership to S. So, and then you can also do it this way as well. So toString exists on initial content on the literal string that you can just convert to. Or you can do a string from, so you can give it a string literal here, or an at string slice, and then it will do create a new string from that as well. So there's a couple of ways of doing it. It's interesting. I kind of flip between them. I don't really know the correct way to do it, to be honest. I kind of use this, which is like the literal string, and then calling the function toString, the member function toString on that. It'd be interesting to hear from other people if they've got any strong ideas about what they prefer, because I'm a little bit in no man's ground with this one.
I quite like string from just because it kind of makes me feel like I'm allocating, which I am.
Yeah.
But it doesn't really, they're identical under the hood from what I've read. So
Yeah, I need to kind of stick to one, I think. But yeah, you're right. So here's just an example of these strings being used, and this is all. So yeah, it was recommended in chat that OS strings are good for reading command line arguments. Yeah, so in Windows, invalid UTF-8. Okay, yeah, that kind of that makes sense. So yeah, storing UTF encoded. Yeah, so this is just an example of some of the UTF-8 encodings, which you can just stick in a string. So how can we append strings? Well, we can use a push string or pushstr member function. So we can just push in, or we've got a string literal here, and it will just kind of grow. Or if you want to push an individual character, we can push in that character as well. And then, well, it's pretty simple, really. So concatenation. Now this is where I really struggled with strings in Rust. Is that with concatenation is when you add two strings together. But in Rust, what happens is that it takes the ownership of like the first one, and then it appends a copy from the other one. So you have to do that as a reference, and then you're basically taking ownership of one. So you lose S1 now becomes S3, and it is quite awkward to work with. But you can, yeah, so concatenation is awkward by using the plus symbol. But what I use now and forever is the format macro, which just works like printl basically. So what you do is you just kind of write in the string that you want, and then you substitute where you want the values with curly braces, and then you just line those up in the function parameters in this macro.
One thing that I thought was kind of interesting about format though is that because it doesn't move from S1, it means it's doing an additional allocation, almost certainly, because it's creating an entirely new string. Whereas in the original example, when it's doing that plus, the second string is not moved from, the third string is not moved from, but the first one is moved from, which means that it doesn't need to move, which is it's worth. In 9 times out of 10, it's not actually going to make a difference because it's unlikely to be the performance bottleneck. But this, I think, will be probably slower than doing plus. That's one thing although the syntax is a bit awkward for concatenation, it does make it clear what's happening. Whereas I find in C++ it's not always completely obvious what's happening under the hood. So you can end up doing loads of extra copies that you don't realize you're doing.
Yeah. Okay. Well, yeah, it's very astute insight there, Kira. If you're doing any type of string manipulation within a tight loop, that's kind of questionable anyway. So yeah. Well, for ease of use, I kind of use format. But in the chat in January, we're supposed to be getting a rudimentary interpolation like F strings and Python. Well, that'd be very interesting. I wasn't aware of that. Right. Okay. So UTF-8 encodings. Right. So you might be better suited to talk about UTF-8 encodings, Kira, like a quick background on what UTF-8 and how it's different to.
I do love UTF-8. You make a good point. So the key thing with UTF-8 is that it only uses the number of bytes that it needs in order to fit in characters. So whereas in the Unicode standard, it's currently done as you need 32 bits to be able to store all of the UTF standard, but you don't normally need all of those 32 bits for the vast majority of characters because they're at the very start of the Unicode standard. So what UTF-8 does is you use a certain amount, and then there'll be a flag that tells you, oh, I need to use the next one. So then you'll use the next byte. And then if you need to go again, then, oh, there's another byte that you can use, and it will be, up to your 4 bytes will be which will give you all of the Unicode set of code points. But the end result is obviously that encoded, you have a variable number of bytes per character, depending on where that character is in the UTF standard, in the Unicode standard, sorry. So that's why you end up with a variable number of code points. So you won't necessarily know the length of your UTF-8 string unless you know where those code points are in the Unicode standard, if that makes sense. And that's why Rust gives you these tools where, yes, we're storing UTF-8, but if you want to access the characters, which are the Unicode standard characters, they're not necessarily all drawable, but they're all Unicode standard characters, then you can use the methods that they provide to iterate over those instead. Or if you know that you want the bytes, then you can get access to them as well, if that makes sense.
Yeah, thank you, Kira. So yeah, in this example here, the encodings for hola would be 1 byte per character, but in this Cyrillic word, which I assume is hello in Rush, don't hold me to that, it'll be 2 bytes per character. So if you indexed into 0 here, you'll get the H. If you index 0 here, you'll just get the first byte in this encoding, which is going to give you gibberish. So how can we get around that? Well, we can use iteration to get characters. So we can take this string literal and we can just, for each character, we can print it out, or if we just want the bytes for each character, we can do that as well. But because, we're basically getting a collection of characters here, we can use, all our collection functions. So we can use get. So we can use get, the first element in that string, which is, how we kind of get around with indexing within strings with UTF-8, which is pretty nifty. Okay, so storing keys with associated values and hash maps. Well, basically just talking about hash maps and Rust. I'm very biased with this, so I'm not a fan of hash maps with their performance. I do understand their utility, and they can be quite useful, but I believe in the performance of a vector over a hash map, but I will like to be proven wrong. So anyway, so what is a hash map? Well, it's a collection of keys with an associated value, and it's important that these keys and values must be of the same type. And we're kind of looking into now how that kind of works. So we create a hash map because it's a collection with hash map new, and then we can add the elements with insert, and we can pass in the key and the value. So again, just like a vector, the type is derived by the values that you're kind of sticking into it. So here our key is the string with blue, and its value is 10. Here we've got a yellow string and its value is 50. And we're going to look into how we can get that out now. So we can get these values out by using get. So here we got scores, which is our hash map, and we can use the get member function, and we can pass in the string for team name, which in this case is blue. So it's going to go and look up or find the key blue within the hash map, and then it's going to return its value here into score. But because HashMap is a collection, you can just iterate over it. And in this case, what we're using is a tuple to get these values out of the score. I love this about Rust, but I think we've already covered it, so I'm not going to go into detail here. Okay, so it's important to know with hash maps that if you use insert, it will overwrite the key value pair that's there. But if you use or insert, the book suggests that if there is no value there, then it's overwritten. So it overwrites if there's no value associated with that key. So if there is a value associated with that key, then it will not overwrite. So it saves you having to kind of check, hey, has this key or this value been set to this key already, if that's important for you. Cool. All right. So I kind of blitzed through the hash map there quite quickly, but effectively, chapter 8 and summary, all collections are effectively iterators, and that gives you power, gives you powerful functions like the filter member function, map, and find. Those are 3 really powerful functions that allow you to manipulate those collections. I'm not sure. I'm pretty sure. I don't know if you've already kind of covered these, but I'm sure they'll go cover that later in the book, using these in more detail because they're very powerful and it gives you more of a functional approach to programming in Rust. Rust text data or strings is all encoded in UTF-8, and that's very important. And I've already gushed about it enough, and I think we're all gushing about it. And there are hash maps. if you want to use a hash map. But they are still effectively iterators. I'm not singing HashMaps praise particularly well at the moment, but there we go. Right, is there any kind of questions about chapter 8 here before we kind of finish up? And Kira's got some end of house things to talk about. Oh, okay, so I found the HashMap entry API pretty amazing. Okay, well, I'm very happy that you did.
Their split white space example of like counting the words, I thought was a really nice example for how to use that.
Okay.
It was pretty cool.
Yeah, I think hash maps with any sort of kind of like text parsing is quite powerful, particularly if like, if you're making your own kind of scripting language, or I think that becomes particularly powerful then. I don't find much use for it.
I had to look like because obviously they only mentioned those 3 collections, which is kind of, I was like, I'm sure they must have the other ones in Rust, even if I haven't used them. So I did look, and they do have double-ended lists and linked lists, and they do have binary tree maps, which might be your preference, Chris, if you were saying you didn't like hash maps.
Yeah. Yes.
And they have binary tree sets and hash sets and binary heaps as well.
But we were just covering what was in chapter 8.
Yes. So. Yeah. No, I only looked at the names. I haven't looked at. I think they've tried to keep the interfaces for everything very similar, which is nice.
Cool. All right. So yeah, any questions about chapter 8 before Kira takes over? Great. Thank you very much, Kira.
Yeah. Do you want to skip on to the next slide? And thank you, Chris. Clap, clap, clap. That was awesome. I know it's not the easiest chapter to cover. These packages are quite there's a lot you can talk about if you have the desire. So basically we're trying to figure out when we want to do the next meetups, because we are getting perilously close to Christmas. The next 2 chapters are error handling and generic types, traits, and lifetimes. The generic types, traits, and lifetimes in particular is a really awesome one and a really important one, and I think it would be really nice if we could cover that next session. However, we're also trying to figure out dates for things. We think we can probably fit in one more meetup of the Rust Book Club before Christmas, because the Thursday before Christmas is like the 23rd, and then the Thursday after is the 30th, both of which I think probably people will be out for either or. So we're thinking we'll after the next meetup, we'll break for Christmas and then come back on the 6th of January with those 2 final chapters, one of which is the command line tool, which will be quite a fun one to come back on, because people have had a chance hopefully to play around with it over Christmas and get it going. The next Thursdays then available are the 9th of December or the 16th of December, but neither me nor Chris nor Alex can make the 16th. So we've proposed these 2 options for when we'll do the next few meetups, and I wanted to get people's thoughts on which one they can do. The options are for covering Rust books chapters 9 and 10, which includes that awesome one on lifetimes, is either Thursday the 9th of December, which is 2 weeks from today, or Wednesday the 15th of December, so that is changing day of the week. I put the poll out, so please let us know which one of those, and that will then determine when the other meetup. So we're planning on doing a CppCon key takeaway meetup before then, which would then either be on the 2nd of December or the 9th of December, depending on when we decide to do the Rust book one. The nice thing about the 15th is that then there's less of a gap before the next one on the 16th of January. But yeah, pros, cons. And yeah, you can it's multiple choice, so you can check on, I think you should be able to check on both, I think, hopefully, if you can do either and have no strong preference. But if you do have a strong preference, then pop it down. Okay, I think most people have filled it in for when the next one. I will share the results. Okay. Right, so we have a slight majority for the 15th. I will add in my vote for the 15th. So I hope that those who put Thursday the 9th can also make the 15th. If not, it will be recorded. Because it's such an important chapter, like if we want to do a second session on it, we can definitely do that. There's no downside to that for this particular chapter, which means, yeah, we'll be having the next regular Rust and C++ kind of talks meetup, which will be more of a C++ one about CppCon takeaways on the 9th of December. Then we'll do Rust chapters 9 and 10. I'm hoping that Richard will take the lead on that one. They're going to be, yeah, really good chapters to cover. And then break for Christmas, come back, command line tools. Going to smash through this book in no time and be building some awesome Rust things. Yeah, that was the main thing I had. I think, did I have one more poll? Just to check, like, my strong preference is to cover chapters 9 and 10 next time, but we don't have to do that. If people would rather wait and cover that after Christmas, we can do that. Or if they would rather just cover generic types, traits, and lifetimes, then we can do that. So just thought I'd put it out there in case people want to cover them in a different order to the book, or a different number of chapters next session. They're both really good chapters, and we'll cover them all at some point. So it's just deciding what order works best for people to give the opportunity to get a handle on everything. Okay, awesome. I will end that. We have a slight majority for chapters 9 and 10, which is obviously sticking with the book, which is good. So yeah, that's everything I had. Exciting for the next meetup. Yeah, I don't know if anyone had any other takeaways from those chapters that they wanted to bring up, or anything they stumbled across they thought was weird or interesting. Oh, one thing I thought was worth mentioning is that the insert method on map does take ownership. So if you've created your string beforehand, for example, if your key is a string, then it's just worth remembering that if you insert it, you will be moving that string into the hash map, unless you've done a clone on it.
That's the same with vector, though, isn't it?
Yes. Yeah. I think it's just more common I think, to put strings in hash maps. So, and then you might potentially then want to reuse it later. So it's just, I think, more of a easier one to trip up on. Yeah. Well, we've gone slightly over, 7 minutes over. Anyone got any other comments? Shall we wrap it up?
I think we're done, Kira.
Yeah, awesome. Thank you again, Chris. That was great. And if anyone wants to take if any of the chapters coming up look interesting to you, and for anyone who wants to present it, I think, Chris, you can vouch. It's quite a good thing to do, I think, to cement the chapter. Did you enjoy it?
Yeah, sure.
Good.
I really appreciate the comments that we had in the chat, and also the comment that I think from Dennis. I think it was Dennis, about packages. So I really appreciate that. Thank you so much.
Yeah, definitely. Thanks everyone for coming, and see you all next time.
Bye bye, everybody. Bye bye.
See you.
Bye bye.